guys, welcome to this tutorial on solving linear equations part 2. In this tutorial, we're going to look at more complex problems involving linear equations, such as those dealing with fractions and the application of linear equations. All these questions are based on an analysis of 20 past exams. So in the first equation here, we have a half y equals 7, and we need to find the value of y that will make this equation true. We want to end up with only a y on the left-hand side of the equation. So we want to get rid of this half here. Since we are dividing by 2 on the left-hand side, we do the reverse on both sides, and we multiply both sides by 2. Then on the left-hand side, the 2's will cancel, and we are left only with y. So y then will equal 7 times 2, which is 14. We can check our answer by plugging 14 back in for y into the original equation, and we'll get a half times 14, which does give us 7. So we know this answer is correct. Then in number 2, we have 3 over 2x equals 6, and we need to solve for x. We want to get rid of the fraction here on the left-hand side, and since we are dividing by 2, we can get rid of it by multiplying both sides by 2. So we basically do the reverse on both sides and multiply by 2. Then the 2's will cancel here. And on the left-hand side, we are left with 3x. Now we can get rid of the 3 here. We are multiplying by 3 here. So 3x means 3 times x. So to get rid of the 3 here, we do the reverse and we divide by 3 on both sides. Once again here, the 3's will cancel, and on the left-hand side we'll only be left with x. The third equation here is a little bit more complicated because we have a fraction and we are subtracting a number from the left-hand side as well. Now, as a rule, we can always first get rid of whatever we add or subtract on the left-hand side. In other words, we can first get rid of this negative 1 here. And we can do so by taking the negative 1 to the right-hand side and add it to the right-hand side. So when we take the negative 1 to the right-hand side, it becomes positive 1. And of course, we can simplify the right-hand side. It comes to negative 2. Now we can get rid of the fraction here. And since we are dividing by 4, we can multiply by 4 on both sides. So once again, we do the reverse. And we multiply by 4 on both sides. So the 4's will cancel here. And then on the left-hand side, we are left only with a p. And negative 2 times 4 is negative 8. Then in number 4, we have 15 over x equals negative 3. Once again, we want to get rid of the fraction here. And since we are dividing by x, we can multiply both sides by x. Then on the left-hand side, the x's will cancel, and we are left only with 15. On the right-hand side, we have negative 3 times x, which is negative 3x. We want the x to be on the left-hand side, so we can flip the equation. Now we want to get rid of the negative 3 here. And since we are multiplying on the left-hand side the x by -3, we divide by -3 on both sides. So on the left-hand side, the negative 3's will cancel, and we're left only with x. And then 15 divided by -3 is -5. Let's look at number 5. Once again, we want to get rid of the x here on the left-hand side, or of the fraction. And since we are dividing by x, we can multiply by x on both sides. Then on the left-hand side, the x's will cancel, and we're left only with 30. We want the x's to be on the left-hand side, so we flip the equation. And finally, we can get rid of the 6 here. And since we are multiplying by 6 here on the left-hand side, we divide by 6 on both sides. So then the 6's will cancel here, and we're left only with x on the left-hand side. And of course, 30 divided by 6 is 5. Then in number 6, we have 1 minus p divided by 3 equals 4. We want to get rid of the fraction on the left-hand side. And since we are dividing by 3, we multiply by 3 on both sides. Then the 3's on the left-hand side will cancel, and we are left only with 1 minus p. Now we want to get rid of this 1 here on the left-hand side. Now note that this is actually plus 1, even though we don't write the plus. So we can take it to the right-hand side, and it becomes -1. So we can subtract it from the right-hand side. So 12 minus 1, of course, is 11. We still have a negative in front of the p here that we want to get rid of. And this is actually -1p, even though we don't write the -1. So since we are multiplying p by -1 on the left-hand side, we can divide both sides by -1. Then the -1's here will cancel on the left-hand side, and we're left only with p, and 11 divided by -1 is -11. So in this equation, we have fractions on both sides, and we want to get rid of both these fractions. On the left-hand side, we are dividing by x, and on the right-hand side by 3. So to get rid of both these fractions, we're going to multiply both sides by 3x. Then on the left-hand side, the x's here will cancel, and we're left with 3 times x plus 5. So 3 times x plus 5. And we can multiply the 3 by the x as well as by the 5. So 3 times x will give us 3x. Then we have the plus, and 3 times 5 is 15. On the right-hand side here, the 3's will cancel, and we're left with 7 times x, which is 7x. We want all our x's to be on the left-hand side and our numbers to be on the right-hand side. So we're going to bring the 7x to the left-hand side. Now notice this is actually plus 7x or positive 7x. So when we bring it to the left-hand side, we're going to subtract it from the left-hand side. We're going to take the 15 to the right-hand side, and since it's positive 15, it becomes negative 15. So 3x minus 7x is negative 4x. Now we can divide both sides by negative 4 in order to get rid of the negative 4 here. Then the negative 4's here will cancel, and we're left only with x. And of course, a minus divided by a minus is a plus. So this is 15 over 4. And we can do this on a calculator. So 4 into 15 goes thrice, and that gives us 12. So we have 3 left, and that will give us 3.75. Then in number 8, we have fractions on both sides of the equation, and we are also subtracting a number from the left-hand side. As mentioned before, as a rule, we can always first get rid of whatever we're subtracting or adding to the left-hand side. So we're going to get rid of this negative 1 here by taking it to the other side, and it becomes positive 1. So we add it to the right-hand side. And we can simplify this. This is 1.5 or 3 over 2. Now we want to get rid of both fractions. And we're going to multiply both sides by the least common multiple. In other words, the smallest number into which both 16 and 2 can go. And that, of course, is 16. So we're going to multiply both sides by 16. Then on the left-hand side, the 16s will cancel, and we're left only with 3w. On the right-hand side, we have 2 that can go into 16, 8 times, and then 3 times 8 is 24. Now we want to get rid of the 3 on the left-hand side. And since we are multiplying by 3 here, we can divide by 3 on both sides. So the 3's will cancel on the left-hand side. And we are left with w equals 24 divided by 3, which is 8. In number 9, we have fractions on both sides of the equation. And we want to get rid of them. On the left-hand side, we are dividing by x plus 3, and on the right-hand side by x plus 5. So to get rid of both these fractions, we're going to multiply both sides by x plus 3 and x plus 5. So let's do that. So multiplying the left-hand side by x plus 3 times x plus 5. And then also multiplying the right-hand side by the same. Then on the left-hand side, the x plus 3 here will cancel with the x plus 3 here. And we're left only with x plus 5 times 5. So we're going to multiply this 5 here into the brackets. So x times 5 will give us 5x. Then we have a plus, and 5 times 5 will give us 25. Then on the right hand side, the x plus 5 here will cancel with this x plus 5. And we're left with 3 times x plus 3. So here we're going to multiply the 3 into the brackets. So 3 times x will give us 3x. Then we have a plus. And 3 times 3 is 9. We want all our x's to be on the left hand side and all our numbers on the right hand side. So we're going to bring this 3x across to the left hand side. And it's going to become negative 3x. Remember, there's a plus here that we don't write. So when we bring the 3x to the left hand side, the sign will change. Then we're going to take the 25 to the right hand side, and it will become negative 25. Then 5x minus 3x is 2x. 9 minus 25 is negative 16. Now we just need to get rid of the 2 here, and we can do so by dividing both sides by 2. So here we see that on the left hand side, the 2's will cancel, and we're left only with x. And then negative 16 divided by 2 is negative 8. So in this equation, we have a fraction on the left hand side, and we need to get rid of it. Since we are dividing by 5 here, we do the reverse and multiply each term in the equation by 5. So then multiplying the first term by 5, and also the second term, and not to forget to also multiply the right hand side by 5. So 5 times 3 is 15. Here the 5's will cancel, and be left only with x plus 2. Now we can multiply the 15 into the brackets here. We can add like terms on the left hand side, so 15x plus x is 16x. Negative 60 plus 2 is negative 58. We want to isolate the x on the left hand side, so we can move the negative 58 to the right hand side, and it becomes positive 58. So we add it to the right hand side. Finally, we want to get rid of the 16 here, and since we are multiplying by 16 on the left hand side, we divide both sides by 16. And the 16s will cancel here, and now we're left with x equals 88 over 16. This we can do on a calculator. And it's 5.50. So in number 11, we want to get rid of the fraction here. And since we are dividing by 5, we multiply each term by 5. So each term in the equation we multiply by 5. Then also the right hand side, we multiply by 5. So 5 times 3 is 15. Here in the second term, the 5's will cancel, and be left with 2 into x plus 2. Now we can multiply into the brackets. 15 times 3 is 45. 15 times negative x is negative 15x. Here we have negative 2 times x. And negative 2 times positive 2 is negative 4. Now we can add the like terms on the left-hand side. So 45 minus 4 is 41. Negative 15x minus 2x is negative 17x. We want to get rid of all the numbers on the left-hand side. So we can take this 41 to the right-hand side. So it becomes 5 minus 41. So when we take this 41 to the right-hand side, the sign must change. So 5 minus 41 is negative 36. We can divide both sides by negative 17 here. The negative 17s will cancel here. And we're left only with x equals negative 36 over negative 17. Of course, a minus divided by minus is a plus, so these negatives will cancel. And 36 divided by 17, we can do on a calculator. And it's 2.12. So x is 2.12. So the rest of the questions in this tutorial deal with application problems involving linear equations. In number 12, it says, in this question, all lengths are in centimeters. The diagrams are not drawn to scale. And we are given a rectangle here and a square over here. It says, find the value of x when the perimeter of the rectangle is equal to the perimeter of the square. So the perimeter of the rectangle will be all these sides added up. The width of the rectangle is 2x plus 1, and we have two such lengths here. So it's twice 2x plus 1. Then the length is 2x plus 6, and we have two such sides. So we add twice the length. And this gives us the perimeter of the rectangle in terms of x. Now, this must equal the perimeter of the square. The one side of the square is 3x minus 1, and there are 4 such sides. So we need to multiply 3x minus 1 by 4. So we've set up our equation, and now we simply evaluate it or solve it. We can multiply the 2 into the brackets here, as well as over here. And then we multiply the 4 into the brackets on the right-hand side. Now we can first add like terms on the left-hand side. So 4x plus 4x is 8x. 2 plus 12 is 14. We want all our x's to be on the left-hand side. So we can bring the 12x to the left-hand side. Of course, this is positive 12x. So when we bring it to the left-hand side, it becomes negative 12x. We can also take the 14 to the right-hand side. And since we are adding 14 on the left-hand side, we subtract it on the right-hand side. So 8x minus 12x is negative 4x. Negative 4 minus 14 is negative 18. We want to get rid of the negative 4 here, so we can divide by negative 4 on both sides. The negative 4s will cancel here, and we're left only with x on the left-hand side. Then a minus divided by minus is a plus. So these negatives can cancel. We can do this on a calculator. 18 over 4 is 9 over 2, which is 4.5. So x equals 4.50. And this, of course, is in centimeters. So in number 13 it says, At a football match, the price of an adult ticket is X dollars, and the price of a child ticket is X minus $2.50. There are 18,500 adults and 2,400 children attending the football match. The total amount paid for the tickets is $320,040. Find the value of an adult ticket. So to find the money that came in from the sale of adult tickets, we have to take the number of adults and multiply it by the price paid per adult ticket. So that's going to be 18,500 times X. Then to get the money that comes in from the sale of child tickets, we take the number of children and multiply it by the price paid per ticket. This will give us a total amount that came in from ticket sales. And we know that that must come to 320,040. Now we can simplify. We can multiply the 2,400 into the brackets here. Then 2,400 times 2.5. Gives us 6,000. Now we can add like terms on the left hand side. So 18,500x plus 2,400x. That we can do on a calculator. And that comes to 20,900. So 20,900x. Then we can take the 6,000 to the right hand side. So 320,040 plus 6,000. Once again, we can do this on a calculator, but it comes to 326,040. Then finally, we can divide both sides by 20,900. The 20,900s here will cancel, and we're left only with x. And we can evaluate the right-hand side on a calculator. And it comes to 15.6. So $15.6 or $15.60. So it says here, Ahmed sells different types of cake in his shop. The cost of each cake depends on its type and its size. Every small cake costs X dollars and every large cake costs 2X plus $1. In 8 says the total cost of 3 small lemon cakes and 2 large lemon cakes is $12.36. Find the cost of a small lemon cake. So we can use the information given in A to set up an equation. The total cost of 3 small lemon cakes and 2 large lemon cakes is $12.36. So in order to work out how much money he earns from selling 3 small lemon cakes, we have to take the number of lemon cakes or small lemon cakes multiplied by the price per cake. And we know that it's X dollars per cake. Then we have to add to it 2 large lemon cakes. And we know that the large lemon cakes sell for 2X plus 1 each. So 2 times 2X plus 1. This must give us a total of 12 36. So we can solve this equation. We can multiply the 2 into the brackets here. Now we can add like terms on the left-hand side. So 3x plus 4x. And we can take the 2 to the right-hand side and subtract it from the right-hand side. So 1236 was 12.36 minus 2. Now we can get rid of the 7 here by dividing both sides by 7. So on the left-hand side, the 7s will cancel. And we're left only with x. And then on the right-hand side, we have 10.36 divided by 7. And then that comes to 1.48. So x is $1.48 or $1.48. Then in B it says the cost of one apple is 15 cents. The cost of one orange is 18 cents. And the total cost of all the fruit is $5.55. Find the cost in cents of one banana. Now, first we can work out how many of each fruit she buys. So we know that she bought X apples, and in A we found that X was 6. So she bought 6 apples. Then the oranges is X plus 7. And we know that X is 6. So the number of oranges she buys will be 13. The number of bananas is 2x minus 1. So we can plug in 6 for X. And we see that she buys 11 bananas. Let's first work out how much she spends on apples and oranges. So apples plus oranges. So there's 6 apples at 15 cents each. And there are 13 oranges at 18 cents each. So let's see what this comes to. And it comes to 324 cents. So 324 cents. Now, we also know that she buys 11 bananas, and we need to work out how much each banana costs. We also know that she spends $5.55 on all the fruit. We're going to convert this to cents. So it's 555 cents. So then the bananas, or the cost of the bananas, will be 555 cents less the 324 cents that she spends on apples and oranges. And that's 231 cents. So 231 cents. We know that she bought 11 bananas. So therefore, the price of one banana will equal 231 cents divided by 11. And that comes to 21 cents.